मिनिमाइज करू का? Hello students, topic of superposition of waves. Topic to be covered: vibrations of air columns in a pipe closed at one end. Next point, vibrations of air column in a pipe open at both the ends. And third one, practical determination of end correction. In last lecture, we already seen what is the meaning of end correction. Now, the next point is that vibrations of air columns in a pipe closed at one end. See here. Now, the vibrations consider a long cylindrical tube closed at one end and consists of air column with rigid boundary at one end. When a vibrating tuning fork is held near the open end of the closed pipe, sound waves are sent by the fork inside the tube. Longitudinal waves traveling along a pipe of a finite length are reflected at the ends of the transverse waves are reflected at the fixed ends of string. The phase of the reflected waves depend on whether the end of pipe is closed or and how the wide or narrow the pipe is compensation to the wavelength of the longitudinal waves like a sound wave. Now say in this picture, first of all, see in this picture, here is the one wave boundary, second point, the end point is closed at the boundary and open end tuning fork is held here, which is the source of sound where the length capital L is nothing but lambda by 4. Now see here, the first modes of vibrations of air column close at one end known as the fundamental modes. That is, the length of air column L is equal to lambda by 4. Therefore, lambda is equal to 4L, where lambda is the wavelength of fundamental mode of vibrations in air columns and N is the fundamental frequency. Now, we note that in 11th standard, what is the exact relation between velocity, frequency and wavelength? And the formula V is equal to N lambda. Now, therefore, N is equal to V upon lambda. Substitute the value of lambda, that is 4L, in the above equation. We get N is equal to V upon 4L. Therefore, V is equal to 4 upon L plus E. The fundamental frequency is also known as the first harmonic. It is the lowest frequency of vibrations of air column in a pipe closed at one end. Then in last lecture we already seen what is the meaning of harmonics and overtones. Now the next point, the next modes of vibrations of air column close at one end. See here in the next diagram, see here in this next diagram, one loop is formed where A is the antinode, N is the node, open end of the tube where antinode is formed, capital L is equal to now 3 lambda 1 by 4, where lambda 1 is the next mode of vibrations. Now see here, the next mode of vibration, it consists of the mode of closed end at antinode at the open end. with the one more node and antinode in between. If n1 is the frequency and lambda 1 is the wavelength of the wave in this mode of vibrations of air column, we have the length of air column L is equal to 3 lambda 1 upon 4. Therefore, lambda 1 is equal to 4L upon 3. Substitute the value of capital L is nothing but small l plus E, where E is the end correction. Therefore, the equation becomes 4L plus E upon 3. The velocity of the second mode is given by V is equal to N1 lambda 1. Therefore, N1 is equal to V upon lambda 1. Now, the substitute the value of above equation, lambda 1 is nothing but 4L plus E upon 3. We get the equation 3V upon 4 into L plus E. Therefore, N1 is equal to 3N. This is the frequency of third harmonic. It is the first overtone. Remember that the overtones are always numbered sequentially. Now the next point. See here. आता next mode of vibration. Now the next modes of vibrations of air column. See here, two loops are formed. A is the antinode, N is the nodes, where A is the antinode, meaning the vibrations of the particles is maximum. Nodes where the particles are at the rest position, where lambda is equal to, capital L is equal to 5 lambda 2 upon 4. See here, the next higher modes of vibrations of air column in above diagram, we get length of air column L is equal to 5 lambda 2 upon 4. Therefore, lambda 2 is equal to 4L upon 5. Therefore, 4L plus E upon 5. Again, substitute this value in equation. V is equal to N2 lambda 2. Therefore, N2 is equal to V upon lambda 2. To substitute the value of lambda in above equation, we get 5V upon 4L is nothing but 5V upon 4L plus E. This is the frequency of the fifth harmonic, is under second overtone. Condition is that similar way for the fifth overtone we get the frequency of NP as the formula is written. NP is equal to 2P plus 1 in bracket and N. Thus, for a pipe closed at one end, only the odd harmonics are present and even harmonics are absent. Next point. Vibrations of air column in a pipe open at both the ends. आता आपण काय पाहिलं? Vibrations of air columns in a pipe closed at one end. Now, the vibrations of air column in a pipe open at both the ends. See here, open at both ends. Now, the three diagrams is there. First mode of vibration, next mode of vibration, and higher modes of vibration. Here in first diagram, capital L is equal to lambda by 2. In next diagram, L is equal to lambda 1, and next modes of vibration, L is equal to 3 lambda 1 upon 3 lambda 2 upon 2. Now, see the derivation one by one. First one, the length of air column L is equal to lambda by 2, or lambda is equal to 2L. Therefore, again the equation, substitute this value lambda, N is equal to V upon lambda. Therefore, V lambda is 2L. Therefore, V upon 2L. And the equation becomes V upon 2 into L plus E. Therefore, V is equal to 2NL. This is the fundamental frequency or the first harmonic. It is the lowest frequency of the vibrations. Now, in the second diagram, see the next possible modes of vibrations of air column open at both the ends as shown in second diagram. See the three antinodes and two nodes are formed. See here, first one, second one, third one, and two nodes are formed. The length of air column lambda capital L is equal to lambda 1. Therefore, lambda 1 is equal to L, that is L plus 2E. Why it is here come 2E? Because open at both the ends, the end correction and the length of the air column L is equal to L plus 2E. Therefore, here due to that of open at both the ends, the end correction is double, that is L plus 2E. If N1 and lambda 1 are the frequency and the wavelength of the modes of vibrations of air column respectively. Then V is equal to N1 lambda 1. Therefore, N1 is equal to V1 upon lambda 1. V upon L is equal to V upon L plus 2E. The equation becomes N1 is equal to 2N. This is the frequency of second harmonic or the first overtone. Now, see in last diagram, see here, capital L is equal to 3 lambda by 2. Now see the derivation of third diagram. In the next modes of vibrations of air columns open at both the ends, as shown in third diagram of that PPT. 4 antinodes and 3 nodes are formed. See here, 4 antinodes, 1, 2, 3, 4, 1, 2, 3. 4 nodes and 4 antinodes and 3 nodes are formed. Therefore, the length of air column L is equal to 3 lambda 2 by 2. Therefore, lambda 2 is equal to 2L upon 3. Rearrange this equation, we get 2L plus 2E. Now the substitute the value of capital L open at the both end nothing but L plus 2E upon 3. If N2 and lambda 2 are the frequency and wavelength of these modes of vibrations of air columns respectively, then V is equal to N2 lambda 2. Therefore, N2 is equal to V upon lambda 2. Therefore, 3V upon 2L. Again, 3V upon 2 into L plus 2E. But V upon 2 into L plus 2 is nothing but N. Therefore, N2 is equal to 3N. This is the frequency of third harmonic or second overtone. From the above these equations, we know that we get that thus all the harmonics are present as overtones in the modes of vibrations of air columns open at both the ends. It may be noted that sound produced by the open pipe contains all harmonics is quality richer than the produced by the closed pipe. Fundamental frequency of vibrations of air column in open pipe is double that of fundamental frequency of vibrations in a closed pipe of the same length. Now see here, fundamental frequency of vibrations of air columns in an open pipe is double that of fundamental frequency of vibrations in closed pipe of the same length. Using the formula or knowing the values of N, L and N correction, the velocity of sound and air at room temperature can be calculated. Now the antinodes are formed little beyond the open ends of the pipe. It is, however, not possible to locate the position of the antinodes precisely. Therefore, in of the antinodes in experiment, the length of pipe is measured and end corrections are incorporated. Now the practical determination of end correction. See here. As exact the method to determine the end correction using the two pipes of the same diameter but different in length, that is L1 and L2 as follows. See here, for a pipe open at both the ends, V is equal to 2N1 L1 and is equal to 2N2 L2. Therefore, N1 L1 is equal to N2 L2. We get N1 L1 plus 2E is equal to N2 is equal into L2 plus 2E. Therefore, the equations, this formula is used in numericals, so that E is equal to N1 L1 minus N2 L2 upon 2 into N2 minus N1 common काढलेला आहे 2 याच्यामध्ये, or N2 L2 minus N1 L1 2 upon N1 minus N2. Same as that of for a pipe closed at one end, V is equal to 4N1 L1 is equal to 4N2 L2. We get 4 get cancel. Now N1 L1 is equal to N2 L2. We get N1 L1 plus E is equal to N2 L2 plus E. Therefore, A is equal to N1 L1 minus N2 L2 upon 2 into N2 minus N1, or the formula becomes N2 L2 minus N1 L1 upon 2 into N1 minus N2. Now, in next lecture, we have to see that vibrations produced in a string. Now, the questions arises on that equations, on that practical determination. First one, vibrations of air columns in a pipe closed at one end. Next, vibrations of air column in a pipe open at both the ends. Equations and derivations are asked. In next lecture, we will see vibrations produced in the string, laws of vibrating strings, sonometer, verification of first law of vibrating string, verification of second law of vibrating string, verification of third law of vibrating strings. Okay.